Welcome everyone to our YouTube channel where we continue looking at trigonometry, particularly breaking down questions on proving of identities. Okay, so if you are new to our channel, consider subscribing, liking and sharing so that you are always updated whenever there is a new upload. Okay, so let's look at this. So for this case, while we're proving, here we work with left hand side to prove it to be equal to right hand side. So it's left hand side we're working with here, and this is 1 plus sine theta all over 1 minus sine theta, then plus 1 minus sine theta all over 1 plus sine theta. So what we'll do here is we'll come up with a common denominator, which is a product of 1 minus sine theta and 1 plus sine theta. So this would be okay. So here we have 1 minus sine theta multiplying with 1 plus sine theta. So now when we divide 1 minus sine theta into everything, into cancel 1 minus sine theta, so we get 1 plus sine theta, which multiplies with 1 plus sine theta, and this gives us 1 plus sine theta, all of this what? Squared. Then we'll add 1 plus sine theta into everything, give us 1 minus sine theta, and this gives us 1 minus sine theta, all of this what? Squared. So now let us recall some things here, or rather algebraic identities, where we have a plus b times, or rather squared is giving us a squared plus 2ab plus b squared. So if you look at this one, this that we have is in the same form as 1 plus sine theta. So I can write this 1 plus sine theta. So this is my rough work here. You see this, this one is my A, my sine is my what? My B. So what do I get for such a case? I'll simply get A squared, which is 1, then plus 2 times A, which is 1, then times B, which is sine theta, like this. Then plus here. B is sine theta. When you square it, you get sine squared theta. So this is what we're going to replace here. Now, the other thing is, if you have A minus B, all of this squared. So the one we're going to use is 1 minus sine theta, because this is what we have here. So if you have something like this, if this is what you have, it will give you the same as say a squared minus 2ab plus b squared. So you can say 1 minus sine theta all squared is in this same form. Hence you get your a is 1. When you square your 1, you get 1 minus 2. 1 is a, then b sine theta, then plus sine theta. Now it will be squared. The other one you have is if you have a minus b multiplied by a plus b, the result you're getting is a squared minus b squared. So this concept is from difference of two squares. The one which we can associate with here is this one, which I have 1 minus sine theta and 1 plus sine theta, which in this case will just be 1 squared, which is 1, then minus sine squared theta. Now recall again that if you have sine squared theta plus cos squared theta, this gives you 1. Hence, if you make cos squared subject, you get cos squared theta to be equals to, subtract both sides by sine squared, so you get 1 minus sine squared theta. Now what we have next, these that we have here, these that we've established here, are the ones we're going to apply here. Alright, so now what do we get? So this therefore gives us, this first part is the one we have there, which is 1 plus 2 sine theta over 8 from this, then plus sine squared theta, then plus 1 minus sine theta. According to our findings here, it is 1 minus 2 sine theta plus sine squared theta. All of this divided by what is down in this case will just be 1 minus sine squared theta according to our findings, because we've already written this. Now what do we have next? We can see that this part is the same as that, hence you get 0. You have 1 on top plus sine squared theta plus 1 plus sine squared theta. Then we're dividing with 1 minus sine squared. According to our findings there, we established this to be cos squared. Alright, now on top, I'll write it here since I still have enough space. 1 plus 1 gives me a 2, then plus sine squared gives me 2 sine squared theta, then all over cos squared theta. Now on top you can see that 2 is common, so we're going to factorize your 2. This therefore leaves with 1 plus sine squared theta. This is all divided by cos squared theta. Now what I do next is I will simply isolate 2, hence I'll have something like 2 times 1 plus sine squared theta all over cos squared theta, like this. Now what we do next is I'll write it here. So this will be 2 open brackets. So what is inside here? For the numerator, I will divide each part with the denominator, so it will be 1 over cos squared theta, then plus sine squared theta over cos squared theta, like this, and I close. So this gives me 2 times 1 over cos squared. According to identities, we understand, so this gives us 6 squared theta, then plus sine squared over cos squared gives us tan squared theta, and close. Now I want you to recall something. Recall if you have 1 plus tan squared theta, the result for this one is 6 squared theta. Hence here I have my 2 outside, then what is 6 squared, I'll replace with 1 plus tan squared. Let's say plus the other tan squared theta. Then this gives us 2 times 1 plus tan squared gives us 2 tan squared. When you distribute 2, you get 2 plus 2 times 2 gives us 4 tan squared theta, and this is what we have here. This one is the right hand side, and our identity is done. Thank you. See you in the next discussion.